For Circles Day 2, we have a new concept. It's called inscribed angles. That's the big thing we're going to talk about tonight. It's not too hard, but there are some important things you want to catch. Make sure you fill out in your packet your pre-lesson assignment for Circles Day 2 as you watch this video. Okay, down the first column will be your notes. The second column will be some examples for you to try. In the third column I left, if you have questions on any certain concept, you can write next to it what your question is so that you're prepared when you come in tomorrow. Let's get started. All right, first thing we want to talk about is an inscribed angle. What an inscribed angle is, it's an angle whose vertex is on the circle. So if we look at the diagram I have drawn up here, angle PQR is an inscribed angle. You can see vertex Q is a point right on that circle. The measure of an inscribed angle, okay, so the measure of our angle is going to be half the measure of its intercepted arc. Okay, so if this intercepted arc was, let's say, 60 degrees, then the measure of our inscribed angle is going to be 30 degrees. Another way to think of that is that the intercepted arc, PR up here, arc PR, is twice the measure of the inscribed angle. So you can think about that either way you want. Either the angle is half of the arc, or the arc is twice the measure of the angle. Depending on the information you're given, you might have to use both ways. Let's go ahead and have you try the example to the right of that top section of notes. Go ahead and try that now and pause the video, and then I'll read you the answer. I'm assuming you paused the video. Hopefully you did well. The measure of arc DE should have been 2 times 38, or what works out to be 76 degrees. Let's go on. Did you know that if an inscribed angle intercepts the diameter, then it's a right angle? Okay, think about that. If an inscribed angle intercepts our diameter, then it's a right angle. So it's saying, since here's the diameter of our circle, this angle is intercepting the diameter. In other words, the endpoints of the angle are also the endpoints of the diameter. Okay? This right here, this inscribed angle, has to measure 90 degrees. Let's think about why that would be. We know a diameter creates a semicircle. Semicircle measures 180 degrees. Half of 180 is 90. Therefore, any time an inscribed angle intercepts a diameter, it's going to be a right angle. Go ahead and pause the video now. Use that idea, along with your idea of right triangles, to solve the example to the right. Pause the video and then unpause it when you're ready to hear the answer. Okay, let's go through the answer. First of all, we can see that angle BEC intercepts the diameter, which means that's a 90-degree angle. We already knew this was 30 degrees, which makes the remaining angle of this triangle BEC 60 degrees. Now you've got to use your idea of 30, 60, 90s. 9 is the side across from 60. To get back to the side across from 30, we have to take 9 and divide by root 3. You guys know we can't leave that root in the denominator, so we're going to multiply top and bottom by that same root, so that we now have 9 root 3 over 3. And then reduce out your 9 and your 3. 9 divided by 3 is 3 root 3. There's your length of BE, 3 root 3. Okay, and in this problem we want to know the length of the radius. To get the radius, we have to have the length of the diameter. The diameter is 2 times the length of the side across from 30. So 2 times 3 root 3 equals 6 root 3 for the whole diameter. There's diameter D. To get the radius, we take the diameter and divide by 2. So 6 root 3 divided by 2 takes us right back to 3 root 3 for the length of a radius. Okay, continuing on. Let's take a look at our third row down. It makes sense that if 2 inscribed angles in a circle or congruent circles intercept congruent arcs or the same arcs, then the angles are congruent. Okay, let's talk about why that might be. Looking at circle up here, I've got inscribed angle PRQ, okay, with intercepted arc PQ. Let's say that intercepted arc PQ has a 50-degree arc. from the 50-degree arc, you want to cut that angle in half to get our angle measure is 25 degrees. Okay, now, if we had another inscribed angle that intercepts that same arc, for example, angle PTQ, we find the angle measure the same way. We're going to take half the measure of the intercepted arc. Therefore, you can see two angles that intercept the same arc are congruent. Go ahead and try example 1, pause the video, and then I'll read you the answer. Alright, I'm assuming you tried that example. Okay, you were to find the measure of angle BFA. This angle right here. Now it's not a central angle, so I hope you didn't use that method. Let's see what we can do. First of all, angle AEC intercepts arc AC, which means it's half that measure, so that angle is 50 degrees. Likewise, angle ABC intercepts that same arc, so that angle is also going to be 50 degrees. Likewise, if you look at the other side, arc BE is intercepted by angle BAE and by angle BCE. Since they intercept the same arc, they must have the same measure. So angle BCE is 41, so this angle here is 41. So we're going to go ahead and we're going to say 180 minus 50 minus 41. And when we do that, we're going to get 89 degrees for the measure of angle BFA. So 89 degrees was that answer. Let's look at our last thing. Did you know if a quadrilateral is inscribed in a circle, then its opposite angles are supplementary? Okay, let's think about why that might be. Getting a quick diagram. Let's get rid of this one. Draw a quick diagram of a circle, and you can draw any quadrilateral that you want. Will work. Okay, so let's call this quadrilateral STAR. Now, let's consider angle S and angle A. Angle S intercepts arc SAR. I'm sorry, arc TAR. Angle A intercepts arc TSR. Do you see how the two intercepted arcs make up the entire circle? Well, if both arcs are making up the whole circle and we're taking half the measures of the intercepted arcs to find the angles, half of 360 degrees is 180 degrees. So opposite angles in a quadrilateral inscribed in a circle should always add up to should always add to So no matter what, opposite angles in a quadrilateral inscribed in a circle are always going to add to 180 degrees. Let's go ahead and have you try example 2, and then after you unpause the video, we'll go through the result together. Alright, I'm assuming you gave that a go. Let's take a look. First of all, I hope you noticed that these were parallel lines, and that these two sides were congruent. That makes this not only a trapezoid from the parallel sides, but an isosceles trapezoid, which means that not only is this angle 82, but so is this angle. After that, we have to do 180 minus 82 degrees, and that's going to give us 98 degrees for the angles directly opposite, both 82-degree angles. So 98, 98, and 82 were the correct answers. If you had any questions on this lesson, go back and watch the video again. If you still have questions, write them down next to the subject that they correspond to in the questions column. Otherwise, make sure to review everything we talked about in class today and be ready to rock and roll with the rest of the circles tomorrow in class. Have a good night.